This is continuing the story of making numbers out of squares. And I've gotten up to 7. We discovered in the last video that you couldn't make 7 just out of 2 squares. It certainly isn't 1 square. You can't make it out of 2 squares. And if you try, you can't even make it out of 3. Okay? You've got to use a 2 by 2 square. Otherwise, there's no way you're going to make it. And then the leftovers are 3, and we already know we had to use 3 squares to make that. So this is the hardest number to make so far out of squares that we've discovered. You need to take 4 squares and put them together. Let's just go on a little bit. 8, we get another break. I'm going to now start reusing here. 8, aha. That's 2 2 by 2 squares. And 9, we get a super big break. Why is that a big break? Think about that for a second. It's because it is a square. To rearrange things a little bit. That is a square number. So that's down back to 1. So already this pattern is getting a little complicated. Well, 10, we can make with 2, and that's certainly the best we can do, because it's not a square number. I'm going through these kind of quickly, but again, the idea is not to show your kid this video. The idea is to just do the first couple and get the idea, and then they can figure it out. It's really not that hard as long as you're patient and they have some interest. Let's do a few more, though, because I want to talk a little bit about the pattern. 11. Oh, goodness. Let's see. That's 11. It's getting hard to count these now. Okay, so, well, let's see. It seems like a pretty smart idea to use that 3 by 3. But then we'd have 2 left over. Well, that's not that good. We had to use 3 pieces. Maybe if we actually were smart, we could use the 2 by 2s instead. We don't want to give up on those. Oh, wait a minute. That's even worse. 2 by 2, 2 by 2, and then that's left over. So it does look like we've got to go back to that 3 by 3. A 3 by 3, a kind of medium-sized square, a single and a single. We have to use 3 pieces. Well, let's see. 12, though. 12, it looks like, okay, one way to make 12 would be, let's move them down to 12. Well, there you go. We could use just 4. That's not so horrible. We had to use 4 for number 7. But wait a minute. What's nice about 12? Well, this is something that, depending on the kid, may or may not see this quickly. But with experimentation, as long as you say, hey, don't forget the 2 by 2, just play. Now it actually perfectly groups into 3 2 by 2 squares. Aha. So that's only 3 also. Okay. And then 13, well, okay. When you go to the next number, there's always a kind of a simple-minded strategy. Just add a single. But that's often not the best one. So let's go back and use the 3 by 3. Let's see if that works now. It didn't work before, but that's because we had 3 left over. Ah-ha-ha. Now we have a square left over. Aha. So 13, we only have to use 2. And so, what were we expecting maybe on the basis of the first few? Let me show you the pattern again. Goes 1, 2, 3. You know, I haven't autofocused in a while. 1, 2, 3, 1, 2, 3. Oh, that's interesting. Does it repeat? No. Then there's a 4, and then 2, 1, 2. Oh, it gets kind of complicated. But that 4, as soon as I saw that 4, maybe we were thinking, oh, pretty soon this is just going to get out of control, and we're going to need so many squares. But it's never gotten even back up to 4 yet. Since then. And the question is, you know, what does this pattern do? And it turns out this is one of the most interesting patterns in math. It has a very famous history in terms of how many squares do you need to make a particular number. I'm not going to give away the answer, but it's a very interesting one to investigate. The other thing you can do is we could go back, and what my son liked to do is not just get the number, like for let's see, like for 13 here, say. Okay, we found this cool way to make it with 2, and I kind of like the elegance of that, not using that many squares, but he didn't really care that much about how many squares you used. He thought it was kind of cool to do it as 3 2 by 2 squares and a single. And we recorded that. And so that's another question. How many different ways can you make one number out of squares? That's also a really famous and cool mathematical question. And you can just keep going depending on how much level of interest or how sophisticated they are, or whether they can count above 20. And you can keep going with this question. Can you make it out of a certain number of squares? How many squares do you need to make it? How many ways can you make it out of squares? And start listing those off if you want. We made a whole little booklet about this, going up to a certain point. Then the really cool thing happened. We got up to let's see if I have enough to do this one. I think I had enough. We got up to a really cool point. Let's see if I was smart enough to steal enough of his toys. I'm not sure. Well, here's a 4x4 square. We haven't used that because that's 16. Haven't used that yet. But we got past that. We almost got to here just in this video. We got past 16. We got into the 20s, and we got to what's the next square number? Is 25. And so here's just the next building block. 5 by 5 square makes 25, the number 25. 25 little blocks in there. But then by that time, we was like, oh, okay, that's a square. That's really nice to know. And so that means you only need to use one square to make the square number 25. Okay, that's great. But we were already interested at that point in the different ways we could make a number. And so I had him think about, well, what else could you do? Could you use like 4x4s and 1x1s? And we did that. And then what he figured out, I know it sounds like I'm always boasting on my son, but again, the essential point is I really think this is, with enough time and patience, this is accessible to just anybody pretty much. Now, not every kid has that kind of patience, but it doesn't require any particular training or ability. What we realized is that if you take a 4x4 and a 3x3, you can do this wonderful magic trick. That those together, that's one way to make 25. That a 4x4 square plus a 3x3 square. This is a really rare thing. We had other numbers that, like, maybe there was a way to make it with 2 squares and then another one with 3 or something like that. But here's one where there's one way to make it with 2 squares, but secretly it really is one square in itself. And you can take these guys and move them over and make it into a square. And we thought that was just a cool magic trick. That you can have 2 squares and they move together and you make it into one. And it doesn't just happen with any kind of random squares. It really is a very special thing. And the way mathematically you'd write that is 3 squared plus 4 squared equals 5 squared. That's another notation that I'm pretty sure he didn't get, but I figured I'd write it down just to have it in front of his eyes. That a 3x3 square plus a 4x4 square is magically exactly another square number. And that's a very special thing. And people who remember their high school geometry remember that that's a Pythagorean triple that has to do with right triangles and all kinds of geometry. None of which I've introduced into this, but it'd be fun to do that. I haven't done that yet with my investigations. But I think that's a good place to stop this video.